A bridge is a structure designed to span physical obstacles such as rivers, valleys, roads, or railways in order to provide safe and efficient passage for people, vehicles, or utilities. In this video, we explore 27 different types of bridges, ranging from simple beam designs to advanced hybrid structures, explaining how each one works and what makes it unique from an engineering perspective. 1. Beam bridge. A beam bridge is the simplest type of bridge, consisting of a horizontal beam supported at both ends. When a load is applied, it pushes straight down on the beam, causing compression along the top and tension along the bottom. The supports, called piers or abutments, transfer the load safely into the ground. Beam bridges are best suited for short spans. 2. Arch bridge. An arch bridge features a curved structure that directs weight along its arc. The vertical load is converted into compression forces that move outward into the abutments. This design makes the arch extremely strong and efficient for medium spans. Its strength comes from how it channels forces through compression. 3. Truss bridge. A truss bridge is built from interconnected triangular units. These triangles efficiently distribute forces, with individual members experiencing either tension or compression. The load spreads through the framework, making the structure strong while using materials efficiently. This design balances strength and economy. 4. Suspension bridge. In a suspension bridge, the deck hangs from vertical cables attached to main cables draped over tall towers. The towers transfer the load into the ground while the cables carry tension forces. This system allows the bridge to span extremely long distances. It is ideal for crossing wide rivers or straits. 5. Cable-stayed bridge. A cable-stayed bridge uses cables that run directly from the tower to the deck without a main draped cable. The towers support the load through cable tension, while the deck experiences compression. This design is efficient for medium to long spans and offers both strength and visual simplicity. 6. Cantilever bridge. A cantilever bridge is constructed using projecting arms that extend outward from piers without support at their free ends. A central span connects the two cantilever arms. Under load, the top experiences compression and the bottom tension. This design is useful for spanning obstacles without scaffolding below. 7. Tied arch bridge. A tied arch bridge has an arch above the deck and a horizontal tie beam below. The tie prevents the arch from pushing outward on the abutments. The arch carries compression while the deck acts as a tension tie. This design is useful when strong abutments are not available. 8. Through arch bridge. In a through arch bridge, the deck passes through the arch, which rises above the roadway. Vertical hangers connect the arch to the deck, supporting it from above. The arch carries compression forces. This design is common in steel bridges. 9. Deck arch bridge. A deck arch bridge places the roadway on top of the arch. The arch supports the deck from below and transfers forces outward into the abutments. It functions as a strong compression system. This type is often used in valleys and gorges. 10. Bowstring bridge. A bowstring bridge resembles a bow with a curved arch and a horizontal tie acting like the string. The tie resists the outward thrust of the arch. The arch works in compression while the tie handles tension. It is a variation of the tied arch bridge. 11. Bascule bridge. A bascule bridge is a movable bridge with a hinged section that rotates upward to allow ships to pass. Counterweights balance the load, operating like a seesaw. This design is common in busy waterways where frequent openings are required. 12. Swing bridge. A swing bridge rotates horizontally around a central pier. It pivots to open navigation channels on both sides of the structure. The bridge remains balanced around its central axis. This type is suitable for narrow rivers. 13. Vertical lift bridge. A vertical lift bridge raises its deck straight up between towers using lifting cables. Counterweights balance the deck as it moves. This allows tall ships to pass beneath. It is ideal where horizontal space is limited. 14. Transporter bridge. A transporter bridge consists of high towers spanning a river with a gondola hanging below. The suspended platform carries vehicles across like a ferry. It eliminates the need for tall approach ramps. This design is used where building a high deck would be too costly. 15. Pontoon bridge. A pontoon bridge is supported by floating pontoons that rest on the water's surface. The load is distributed across these floats and anchored to prevent drifting. It is often temporary or used for military purposes. 16. Floating bridge. A floating bridge is a permanent structure supported by sealed floating elements. It uses flexible joints to handle movement and is anchored underwater. This design is used where deep water prevents traditional piers. 17. Rigid frame bridge. In a rigid frame bridge, the deck and supports are firmly connected without bearings. The entire structure acts as one unified frame and bends together under load. This makes it efficient for short to medium spans. 18. Segmental bridge. A segmental bridge is built from short concrete sections joined together with cables. It is post-tensioned for added strength and constructed piece by piece. This method is ideal for long elevated roads. 19. Extradosed bridge. An extradosed bridge combines elements of girder and cable-stayed designs. It features low towers with shallow cables that reduce deck bending. Less dramatic than suspension bridges, it is efficient for medium spans. 20. Stressed ribbon bridge. A stressed ribbon bridge has a very thin concrete deck with embedded cables. The deck follows a gentle curve and works in tension, similar to a suspension bridge. It is often used for pedestrian crossings. 21. Covered bridge. A covered bridge is typically a wooden truss bridge enclosed with a roof and walls. The covering protects the internal structure from weather, extending its lifespan. The internal truss carries the load, and these bridges are common in historic rural areas. 22. Pedestrian bridge. A pedestrian bridge is designed specifically for foot traffic and carries lighter loads. It can use various structural types and is often decorative. These bridges enhance walkability in urban areas. 23. Aqueduct bridge. An aqueduct bridge carries water instead of vehicles. The channel is supported by arches or beams that transfer the water's weight to supports. Often built from stone or concrete, aqueducts have been used since Roman times. 24. Viaduct. A viaduct is a long bridge made of multiple spans that crosses valleys or urban areas. It consists of a series of arches, beams, or piers that distribute loads across many supports. Viaducts are commonly used for railways and highways. 25. Double-deck bridge. A double-deck bridge has two traffic levels, each carrying separate loads. The structure is designed to handle combined forces from both decks. Often made of steel or cable-supported systems, it maximizes space efficiency. 26. Movable bridge. A movable bridge is any bridge that opens to allow ships to pass. This category includes bascule, swing, and vertical lift bridges. These bridges use mechanical systems and counterweights to balance loads while maintaining both land and water traffic. 27. Hybrid bridge. A hybrid bridge combines features of multiple bridge types, such as cable-stayed and arch designs. It is engineered to meet specific site conditions and optimize strength, cost, and performance. Hybrid bridges are used in complex engineering challenges. So which type of bridge is your favorite? Tell us in the comments section below.